Hey everyone, welcome to this YouTube channel. Today we are diving into a topic that sounds at first look scary, but is pretty much awesome. Why do we say so? Because complex numbers are numbers which are really pretty awesome. Why do we say so? Firstly, to introduce our concept, we're going to talk about the introduction of the imaginary unit, which is the main motivation behind the study of complex numbers. After that, we're going to define a few terms associated with complex numbers. And later on, we're going to talk about basic operations like addition, subtraction, multiplication, and division of complex numbers. Let's talk about the motivation. To quickly talk about the motivation of the reason why we need to study complex numbers, let's talk about solution to some quadratic equations. Consider these two equations, x squared minus 9 equals to 0 and x squared plus 9 equals to 0. If we're asked to solve the first one, I know the first one is very easy to look for the solution. So the solution to this first equation, okay, is given by x squared minus 9 equals to 0. This is the difference of two squares, right? X squared minus 3 squared equals to 0. So we're going to have x minus 3 times x plus 3 equals to 0. So therefore, we have x equals to 3 or x equals to minus 3. These are two real roots, right? But if we're asked to look for the solution to the equation x squared plus 9 equals to 0, we're going to have x squared equals to minus 9. So x squared will be equals to the plus and minus, sorry, this x, not x squared. X will be equals to plus and minus the square root of minus 9. Yo, this sounds scary at first look. What is the square root of a complex of a negative number? At first sight, it looks like it does not exist. Now, this is where complex number come into the picture because with complex numbers, we can rewrite the solution as plus and minus square root of 9 times minus 1 here, the square root of 9 times minus 1, which gives a plus and minus the square root of 9 times the square root of minus 1. This gives a plus and minus 3 times the square root of minus 1. This leads us to what we call the imaginary unit, okay? The imaginary unit, which is given by I equals to the square root of minus 1. Therefore, the solution to the equation is given by x equals to plus and minus 3i. And this is what we call a complex number. Okay? So a complex number is an expansion of the real number system. Okay, the complex number system is an expansion of the real number system whereby we introduce what we call the imaginary unit whereby I is equals to the square root of minus 1. This is the beauty of complex numbers. It gives us the solution to some quadratic equation whereby in normal circumstances, the real number system, we will say it does not exist. But with complex number, we have the existence of the solution to this type of equation. This is really beautiful. Here, we can now move on to the definition of some terms in the complex number system. Let's talk about the rectangular form of a complex number. This is any number written in the form z equals to a plus bi, whereby a and b are real numbers. With the introduction of the imaginary unit I equals to the square root of minus 1. Okay, that's what we mentioned in the previous slide. This gives us the complex number system. What is an imaginary number? An imaginary number is a number associated with I, whereby we have I times any number n, whereby n is a real number. Alternatively, we can define a complex number as a number that has two parts, the real and the imaginary part. In this case, the real part of z is equals to a and the imaginary part of z is equals to b. Here is a simple example. If you're given the complex number z equals to 2 plus 3i, what is the real part of z? The real part is simply 2. What is the imaginary part of z? The imaginary part is that part, or is the coefficient of I, which is 3. So the real part is that part without I, whereby the imaginary part is the coefficient of I. In this case, we have 3. Let's define what we call a complex plane. Take note that a complex plane or an Argand diagram is a geometric representation of a complex number. So take note that the complex plane is similar to the Cartesian plane, with the exception that the horizontal axis is called the real axis and the vertical axis is called the imaginary axis. Take for instance, if you're asked to plot the point 2 plus 3i, 2 represents the real part. So we go on to the real axis, we locate 2, we have 2. And then we move vertically to locate 3, we have 3 up here. So once you've plotted the point 2, 3, what do? We connect an arrow from the origin to the point, and this gives us a point in the complex plane. So the a point in the Cartesian plane is plotted in a similar manner like we plot points in the Cartesian plane with coordinate x, y. Okay? The only difference is the label or the name of the axis that changes. Okay? That is it for the definition of what we call a complex plane. Let's look at basic operations. With complex numbers, we can add and subtract complex numbers. Consider these two complex numbers, z1 plus z2. How do we add up two complex numbers? Whereby we have z1 equals to 8 plus 3i and z2 equals to 9 minus 2i. How do we add up these complex numbers? Take note of the solution. Z1 plus Z2 is given by, we add up the real parts on one side, 8 plus 9, and we add up the imaginary part on the other side. We have 3i minus 2i. Here we have 17 plus, you can do this, you just add the coefficients. Okay, so we're going to have 3 minus 2i, which gives us I. The answer is 17 plus I. Okay? How do we subtract complex numbers? We do in a similar manner where we subtract real parts together. This gives us 8 minus 9. And we equally subtract the imaginary parts together, 3i minus 5i. So this gives us minus I. You subtract the coefficients of the I, imaginary units here. We have 3 minus 5, which is minus 2i. As simple as that. How do we multiply complex numbers? Pay attention to what we're going to do here. Do you remember how to multiply algebraic expressions? So we do in a similar manner. So we're going to have 1 plus 2i times 4 minus 3i. So you multiply 1 times 4, which gives us 4. You multiply 1 times minus 3, you're going to have minus 3i here. 1 times minus 3i, the answer is minus 3i. You multiply 2i times 4, the answer here is 8i. You multiply 2i times minus 3i, you're going to have minus 6i squared. Remember, I squared is equals to minus 1. Okay? because I is equal to the square root of minus 1. Therefore, I squared is equal to minus 1. So if you place I squared by minus 1 to obtain 4 minus, here we have 3i plus 8i. We have, here we're going to have 5i here. So we're going to have here 6 times minus 1. This gives us 4 plus 5i plus 6. You collect the real parts together. 4 plus 6 gives us 10 plus 5i. And that's it for the multiplication. For division, to see how we can divide complex numbers, it's very important to introduce what we call the complex conjugate of a complex number. It is that number obtained by changing the sign of the imaginary part. Consider, for instance, z equals to 2 plus 3i. What is the complex conjugate? The complex conjugate is simply denoted by z bar equals to 2 minus 3i. Simply because the sign of the imaginary part here is a plus. Therefore, with the complex conjugate, we are going to have a negative number, a negative sign here in the middle. Now, how do we divide complex numbers? If you have, for instance, a complex number z1 equals to 1 plus 2i and z2 equals to 4 minus 3i, how do we do that? We're going to multiply top and bottom by the complex conjugate of the denominator. So we're going to have z1 times z2 bar, the complex conjugate, divided by z2 times z2 bar. This gives us what? 1 plus 2i, okay, times 4 plus 3i, divided by 4 minus 3i, times 4 plus 3i. So you multiply the numerator as we've shown you on the previous slide. Multiplication is done as what we did in the previous slide. You do multiplication of the numerator, you do multiplication of the terms in the denominator, and then you simplify. After simplification, we are going to obtain minus 2 divided by 25 plus 11 divided by 25i. And that's it with regards to the introduction to complex numbers. So what did we study in this unit? We have studied the motivation. Why do we need to study complex numbers? We've seen that they are very important because it gives us the possibility of getting the solution to some equation for which in a real number system it would not exist. We've defined a few terms associated with complex numbers, and we've looked at some basic operation, addition, subtraction, multiplication, and division. Thank you for following this video up to the end. If you found this content very interesting, feel free to subscribe, feel free to comment, feel free to like and share this video. Thanks so much. See you in the next video.